I'm going to tell you about something you know very well. That is finding area of a square. Suppose the square has side of say 3 by 3. You would tell me the area is 9. Okay, I told you, you know this. But what if I expand the side twice as big, and expand the other side twice as big? That is, I am drawing the square. Well, now this side is 6, right? And this side 6. So what's the area of this big square without this? I'm talking about this pink square. That would be 36, right? Now, I want you to realize that this 36 is 4 times 9. That's no coincidence. Let me be completely abstract so that you can see. So here I had smaller ones, so let's call this side A and A. What would be the length of the big one? That would be 2A, no? Let me do it here so that you don't get confused. It would be 2A. Okay, so the small a's, the dark one's area would be A squared. What would be the area of the big one? 2A times 2A, no? Base times height. That's how you find the area of a square. That is 4A squared. Aha. It is 4 times. Doesn't matter what A was. So, but this is what you got to realize here. If I made the side 2 times as big, then area will be square of that. It was 2 times, so therefore it's going to be 4A squared. Now I went ahead of myself. Suppose these were B, and well, the drawing is out of scale, but suppose I made this to be 3B. Of course, this will be B squared. What would be the area of this? It would be 9B squared, you see. Because I tripled it, the length got tripled, the area will be 9 times square of 3. So if somebody tells you that they expanded the area, the sides, say suppose this was something, x, and they said the length got extended to be cx. Okay, these are squares. Then what would happen to the area? Well, area will be c squared times bigger. So you don't even have to do the computation. You just know it. It doesn't matter what x was, because this will be x squared. This will be c squared x squared. So it doesn't matter what x squared was. This big square's area will be c squared times that. Okay, this is so obvious that you're wondering why I have to point this out to you. Well, it's not so obvious once you get to some other shapes, such as triangles. Suppose I told you the base was B and height was H. What would be the area of this triangle? Would be base times height divided by 2. Now let me extend the height twice and base twice and come up with a triangle like that. This larger ones, what would be the area of that? Well, this would be twice, I said, right? It's twice the height and it's twice the base. So what's the area of this? Well, base times height. So base times height divided by 2. Compared to what you had before, remember what you had? You had BH over 2. This guy's 4 times that. So this ratio being squared is not what happens to squares only. It could happen to the triangle. Let me show you what I mean here. Let's say the base was A and height was B. Then I want this to be, K times A. And I want the new height to be K times B. Now I'm telling you, this big triangle will be K squared times the smaller one. So maybe these numbers are very unfriendly. For example, they could have said the base was 4.126 and the height was 1.248. They said I extended the base and I extended the height by a factor of 2. How big is the new triangle? All you gotta do is just say it's 4 times. You don't have to compute the number to discover that it was 4 times. Okay, so here's the interesting thing here. Let's stick to our original example of the base got twice, so B, this is 2B, and this is H, and this is 2h. So I'm telling you that this triangle is 4 times this. Okay, because it's twice and twice, it became 4 times. But I want you to realize that the shaded area now, I'm talking about only this part here, shaded area is 3 times that. It makes sense, right? Because this was 1, and the whole thing was 4, so this must be 3. And I also want you to see that when I do this, they all have the same area. In other words, if I do it that way, this would be 1, 1, 1. So if you add up the whole thing, it's 4, but this lower part is 3. So whenever you have a triangle that is splitting like that, doesn't matter what shape the triangle was, could be right triangle or anything, you go for the midpoint of the side, connect it, then the ratio of the area will be 1 to 3. Of course, 1 to 4 for the whole triangle, but I'm talking about this lower part is 3, upper part is 1. That's the property of the triangle, if you have the midpoints here. So I want you to realize that this is not limited to square or even triangles, could be anything in fact. So I could tell you the area is, say, 7. Then I tell you, okay, I extended every single side and made twice as long on every side and got this shape here. You may say, whoa. Well, you may say, or you may not say, whoa, but what's the area of the big one? It will be 4 times because every side got doubled. There are 5 sides. Doesn't matter. As long as it got doubled, and the area will be square of that factor, so will become 4 times as big. Notice here, I could think of this as extended this way, but then again, if I move this here, then you can think of it as this being extended the other way. And of course, if it's in any direction, these are similar figures, so all the angles are congruent, of course. And each length is twice. And if I did it this way, and this would be twice too. So therefore, the area of this shady part is 4 times the area of the inside one.